let us look at volume of solid of revolution. So how to figure out the volume of a solid which has been generated using the revolution of a curve around an axis. So here first we will take the example of a sphere. So we take the semicircle on the x-axis. Y is equal to square root of r square minus x square, whose solid of revolution is a sphere. So if we revolve this semicircle around the x-axis, we get the sphere. Now at a fixed x, cross section is a circle of radius y equal to square root of r square minus x square. At a fixed x, if we cut this sphere by a plane, then we will get a circle whose radius is y, which is square root of r square minus x square. Area of this circle is pi r square, which is equal to pi times radius is y, so y square, which is equal to pi times square root of r square minus x square square. So which means square root will disappear, and we are left with pi times r square minus x square. Now a thin slab of thickness dx has volume dv is equal to area times height, that is a of x times dx. So let's take a thin slab of dx height. Now to get the volume, we have to integrate both sides. So we get v is equal to the integral of dv by dx. From where to where? From R1 to R2. Now here R1 and R2 are what? It is from minus R to R. That is equal to the integral from minus R to R of pi times r square minus x square times dx. Here pi we have times r square minus x square is our area, and the height of that slab of thickness dx. Now integrating this, we get v is equal to pi is a constant, so we take it out, pi times r square x minus x cube by 3 from minus r to r. Taking care of the limits, we get v is equal to pi times r square times r, that is r cube, minus r cube by 3 minus, now we substitute minus r. So we get r square times minus r, which gives us minus r cube minus r cube by 3. Simplifying that, we get v is equal to pi times 3r cube minus r cube, that is 2r cube by 3, minus times minus plus r cube, minus times minus times minus, that is minus r cube by 3. Combining them, we get pi times 2r cube plus 3r cube minus r cube by 3. So finally we can say v is equal to 2 plus 3, 5 minus 1, 4, 4 by 3 pi r cube, which is the volume of the sphere. So this was one method of finding the volume of a sphere. Now this method is called the washer or disk method, because we are slicing this sphere into disks. Now let's look at another method. Now the first step is again take the semicircle, but instead of on the x-axis, now we take it on the y-axis. That is x equal to square root of r square minus y square, where x is greater than or equal to 0. So our semicircle is this on the y-axis. Revolving it about the y-axis gives us the sphere. So it is still the same sphere. Now, when 2 points on the semicircle are revolved about the y-axis, gives the two bases for the outer and inner cylinders. We have taken a point on the semicircle, revolved it about the y-axis, which gives us a circle. Similarly, we take a very close by point and revolve it about the y-axis. And on these, we draw cylinders. So it's very difficult to make out. So let me take it a little bit farther away from each other. So now you can see we have the two cylinders. One is the outer cylinder and one is the inner cylinder. Now, radius of this shell. So this is called a shell or a ring. So radius of the shell is equal to the distance from y-axis, which is equal to x. The height of the shell is equal to y coordinate at the top and y coordinate at the bottom. When we subtract that, we get the height of the shell or the ring. That is equal to square root of r square minus x square minus square root of r square minus x square, which is equal to 2 times the square root of r square minus x square. Thickness of this shell is equal to dx. So thickness means this distance between these two inner and outer cylinders. Now the volume of this shell is equal to 2 pi times the radius times the height times the thickness, which is equal to 2 pi times the radius. Now radius is x times the height. Height is 2 times the square root of r square minus x square. And thickness, which is dx. So as dx changes, the volume of the shell also changes. So which means we can write it as dv is equal to 4 pi x times the square root of r square minus x square dx. Actually, arriving till this point is the main problem. Once we have reached this, it becomes easy because now we are talking of integration. So now integrating both sides, we get v is equal to the integral. Now we are integrating from where to where? Remember, we started with this semicircle. X is greater than or equal to 0. So we are starting from here and going up to this. So 0 to r of dv by dx, which is equal to integral from 0 to r of 4 pi x times the square root of r square minus x square dx. To integrate this, let's do substitution. Let u is equal to r square minus x square. Differentiating it, we get du is equal to r square is a constant, so 0, and minus x square is 2x dx. Remember, here in this, what we have is x times dx is there. So we leave x times dx or x dx on one side and rest we take it to the other side to get x dx is equal to minus du by 2. Now, since we are using substitution method, we have to change the limit. Limits are 0 to r. So if x equal to 0, then u is equal to r square. So this will disappear and we are left with r square. Now if x is equal to r, we have r square minus r square, which is 0. Doing the substitution, we get b is equal to 4 pi times integral from, when it is 0, it is r square. So r square to 0 of square root of u, because r square minus x square is u. So it is under a square root. So square root of u times x dx, which is equal to minus du by 2. And since we have a negative sign here inside the integral. We can get rid of it by exchanging the limits. So 0 comes down and r square goes up. So we have 2 pi, because this 2 in the denominator comes out of the integral, and 2 times 2 is 4. So 2 pi times the integral from 0 to r square of square root of u can be written as u to the power of 1 by 2 du. And now we actually do the integration. So v is equal to 2 pi times u to the power of 1 by 2 plus 1 by 1 by 2 plus 1 from 0 to r square, which is equal to 2 pi times, in the denominator we have 1 by 2 plus 1, which is 3 by 2. Now if we bring it to the numerator, we take the reciprocal. So it becomes 2 by 3 times u to the power of 3 by 2 from 0 to r square. So now 2 times 2 is 4 pi by 3 times, here when we substitute 0, it disappears. So we are left with we substitute it with the r square. We get r square to the power of 3 by 2. So 2 and 2 cancel out, and we are left with r cube. So which means we have v is equal to 4 by 3 pi r cube. Again the same result. And this method is called the cylindrical shell or ring method. Now here remember, I have kept it quite, thickness is very high. As it goes, as I make the thickness smaller and smaller and then integrate, we will get this result. So let's make the thickness of the shell smaller and smaller. Now to summarize, a semicircle is revolved around the y-axis, gives us the sphere. The endpoints of an arc of the semicircle, when revolved about the y-axis, gives two bases for the outer and inner cylinders. So as dx goes to 0, dx is what? Thickness of the shell. As these two circles get closer and closer to each other, as dx goes to 0, shell volume goes to 0. Now volume of the inner solid, that is inner cylinder, is less than the sphere, and volume of the outer solid, that is the cylinder, is greater than the sphere, which means we get the volume of the sphere as shell volume goes to 0. That is on integration from 0 to r. So that was finding the volume of solid of revolution. That is in case of a sphere. Now, if you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.